Okay, this is now the example number 4. I think it's number 4. And the example says that for the magnetic circuit, so here for the magnetic circuit of figure 2, so this is the figure 2, which has n 400 turns, and the mean length of the core is 50 centimeters. The air gap length is 1 millimeter. The areas are the same, 15 centimeters squared. The relative permeability of the core is 3000, and the current of this coil is 1 ampere. We have to calculate what is the flux in this air gap, what is the magnetic flux density here, and what is the inductance of this coil right here. So first let's take a look at this magnetic circuit. I think we had it already. The current is going in this direction, so the right hand rule, these fingers of the coil are showing the direction of the current, and this right thumb is showing the direction of the flux and the flux density of the magnetic circuit. So we have the schematic that looks like this. This is the MMF produced in this coil, plus, minus. Here we have a reluctance of the core, and here we have the reluctance of the air gap. Now the flux is going in this direction, and through all the circuit the flux is going to be the same, so this flux is equal to the flux in the air gap. You already know that. First of all, we have to calculate these reluctances. We know what is the MMF of this coil. And we know the MMF produced by this coil here, which is equal to N times I, and we are going to calculate the flux. For the reluctance of the core, we need to know what is the mean length of the core, and that is 50 centimeters. But we have to transfer that into the basic unit, which is meters. So it's 50 10 to the minus 2 meters. Divided by the permeability is equal to 3000 times 4 pi 10 to the minus 7, multiplied by the area of the core, and the area of the core is 15. It's centimeters squared, but in meters squared that is 10 to the minus 4. Okay, that is equal to 88,42 times 10 to the 3 ampere turns Weber. And now we have to calculate what is the reluctance of the air gap, which is easy stuff to do. That is the length of the air gap, which is equal to 1 millimeters, and 1 millimeter is 10 to the minus 3 meters, divided by the permeability of the air is just mu0, and that's 4 pi 10 to the minus 7, times the area is 15 times 10 to the minus 4, and we get 530 515 10 to the third. Yeah, ampere turns divided by Weber. So I don't have the room to put the unit. Now we can measure what is the flux. The flux is equal to the MMF, that is equal to N times the I, divided by the series reluctance of these two reluctances. Now we have 400 turns on this coil times 1 ampere, so just say like this, divided by the sum of these two. And you get, I'm gonna calculate it right now. Well, I'm gonna do it on my calculator. I'm just gonna do this first. 42 times 10 to the third plus . So this, the flux in the air gap is equal to 6,463 times 10 to the minus 4 Webers. Now it is easy to calculate the magnetic flux density in the air gap, and that is equal to the flux divided by, this is also the same, divided by the area of the magnetic core, or divided by the area of the air gap. And that's equal to 6,463 times 10 to the minus 4 divided by 15 times 10 to the minus 4. These two can cancel each other out, and we get 0,43808 Teslas. Yeah, that's correct. Now we measured the flux and the magnetic flux density in the air gap. Now we have to measure the inductance of this coil, which is very easy. If you watch my previous video, I'm gonna remove this circuit now. There are multiple ways that you can measure the inductance of this coil, and the best way to do it is equal to N squared, number of turns divided by the reluctance of this magnetic circuit. But in this particular circuit we have a reluctance of the core plus the reluctance of the air gap. So that is equal to 400 squared divided by the sum of these two. and I get that this is equal to 0.258 Henry. This is the unit for the inductance, and this is correct. So this is how you measure the inductance of a coil. So if you didn't watch my previous video, you should watch it. So this is it for the fourth example, and in my next video is also one example. We're going to do one more example, then I'm going to move on to the theory that is left in this chapter. See you in my next video.